Imagine building with foam concrete, only for it to mysteriously lose its integrity. Over time, what invisible forces are at play, slowly eroding its strength? We uncovering the hidden factors and little known secrets that lead to foam concrete's unexpected weakening, giving you the insider knowledge to avoid costly mistakes. This foam concrete roof insulation layer quietly subsided 3 months after acceptance, with the deepest depression reaching 15 centimeters. In another project, the foam concrete infill in the walls, extensively powdered after just 1 year, completely losing its strength. These failures are not coincidental. They stem from the insidious US work of a silent killer. Today, we transform into building material detectives to uncover the hidden failure codes behind Ming-Lai perfect formulations. We'll examine how overlooked details can secretly undermine entire building systems. The first killer lurks within the environmental factors we know best. When the daily temperature fluctuation exceeds 15 C, foam concrete undergoes continuous breathing. Thermal expansion and contraction create microcracks at the interfaces of heterogeneous materials. These hairline cracks serve as FAST track pathways for water intrusion. What happens when moisture infiltrates? During freeze-thaw cycles, this water acts like millions of miniature hydraulic presses, constantly pushing against pore walls. In dry conditions, soluble salts crystallize and grow within the pores, producing the same destructive effect. More insidiously, ultraviolet radiation directly degrades the organic polymers on the foam concrete surface, compromising the protective layer and rendering the material brittle. The second killer lurks during the most critical curing stage. Many mistakenly believe surface drying equates to strength development. A fatal misconception. The left specimen was cured under standard conditions for 28 days, while the right specimen underwent rapid drying in a forced ventilation environment. Although their surface hardness appeared similar at 7 days, their compressive strength differed by as much as 40% after 28 days. Why? Because the hydration reaction of cement requires a continuous supply of internal moisture. When the surface dries faster than the internal hydration process, a hard shell, soft core structure forms, generating tensile stresses within that trigger a network of micro cracks. These cracks may not appear immediately, but they lay the groundwork for long-term failure. The most cunning killers lurk within those Ming-Lai perfect bubbles. Ideal pore E should resemble the first set, 0.1 to 0.5 millimeters in diameter, evenly distributed and independent of one another. But problems often arise when Group 2, excessively large pores, 1 millimeter, creates structural weak points. Group 3, interconnected pores form highways, allowing water and corrosive media to penetrate unimpeded. These defects often stem from improper selection of foaming agents or inadequate mixing processes. When foaming agents exhibit poor compatibility with the substrate, bubbles continue to coalesce, and grow after pouring, ultimately compromising the stability of the entire foam structure. To combat these silent killers, we need to establish defenses on 3 fronts. Formulation level. Employing a composite additive strategy. Polymer emulsion enhances toughness. Hydrophobic agents block moisture pathways, and fibers resist microcrack propagation. Process control. Establish a strict curing regimen. Maintain moisture for the first 24 hours, followed by 27 days of protection against excessive moisture loss. Control ambient temperature between 15 to 25 C, 59到77华氏度 with humidity 大于 80%. Design protection. Install a protective layer over the foam concrete to prevent direct exposure to ultraviolet radiation or environments with extreme temperature fluctuations. Remember this critical ratio? Maintain the water to binder ratio between 0.45 and 0.55. The foaming agent dosage must be precise. Lie determined through testing. The curing period must never be less than 7 days. Every instance of foam concrete failure is not the result of a single factor, but rather the outcome of multiple silent killers acting in concert. Understanding these underlying risk mechanisms enables us to establish a more robust defense system in material selection, construction control, and maintenance management. True durability isn't a matter of luck, but rather the result of scientific design and rigorous execution. Share your foam concrete challenges in the comments below. And don't forget to subscribe. See you next time.